what's the technologies that we need to actually bring this all together in a way that if we can't do it in our backyard, one of the richest backyards on the planet, how are we going to do it at Chagos, or how are we going to do it in Palau? So from our tagging program, where hundreds of sharks were tagged, we learned that, for example, salmon sharks in red, white sharks in white, makos in blue, from America waters that are, in some cases, protected. They move out into the subtropical gyre, where they're unprotected, and then seasonally, they aggregate back in America. So what we're thinking about, and what I'm going to show you, is how it is that we can actually keep track of the domain of the animals, and then how is it we can keep track of the animals. So we first have to know what we're trying to protect. I think in ocean conservation, what we really have a lot of trouble with is understanding what's beneath the non-transparent sea. If we don't know what we're trying to protect, we don't know how many animals are in our MDA, we don't know who's there and at what season, I guarantee you it's going to be impossible to go up against a human predator. So what we know is animals go away from California and come back. We've learned that through a lot of effort, through $25 million worth of tagging. And what I began to think about is what would happen if we start putting wired buoys in the ocean and have cheaper tags that talk to these buoys. And one of our friends from Liquid Robotics and Sail Drum are in the room today, could help us with mobile platforms. And then, much as we heard in the first presentation, we could create domain awareness within something as straightforward as our California sanctuaries. So the black lines are our marine sanctuaries. The colors are from our tagged animals over a period of time. And what we've taken on as a challenge with limited amounts of money is, could we put on an inexpensive tag that talked to underwater receivers and then iridium-enabled receivers, and then begin to census something as big as a white shark? So when we put on the inexpensive tags, they can be censused in their locations where the receivers are. These are just different numbers of white sharks sending signal. But what makes it really powerful is that if you tag your white sharks with the inexpensive tag, you can actually follow them for many, many years. And from the comings and goings and reporting into the iridium or the underwater receivers, you can begin to count the animals in your backyard. So only in the last 2 years have we been able to hook this up with a receiver system that doesn't break every season when the big waves come. This is the latest model of the buoy. And these buoys basically are collecting data and now in real time sending it to your iPhone or putting it into our SharkNet app built by our lab, as well as Earth and Sea are in the room today. And we're able to then take an animal that's passing a buoy and make its presence on the planet transparent from a reserve. And it's taken a lot of effort to do this, and this is just Año Reserve. These are the white sharks that were there this year. This is Tamales Point, another white shark coming by, who's been there lately. And you can begin to keep track of what's in your MPA and then make it transparent, as we said. So just from the California perspective of case management, we can only afford 5 buoys right now. I mean, that's how expensive buoys are. And what we need is we need to bring these technologies into a less expensive networked arrangement and then spread them across the entire sanctuary network. Mobile gliders go in the ocean with receivers and instruments on them that give us mobile platforms, such as this wave glider going up and down the California coast, or the sail drone that was visiting Año Nuevo Reserve with similar instruments on board. These are mobile platforms that can be carefully and very, very accurately navigated across very shallow waters. For those of you up close, you can see that's only 30 fathoms that you're operating this machinery in. And then we can specifically run these devices, these mobile gliders, in very tight patterns around reserves that are very, very small, such as Año Nuevo. And then the dots represented here are different large predators. These are 4,000 and 5,000 pound white sharks, and those are pings coming from their tags telling us that we can keep track with mobile gliders of their presence on the planet. We've also run these gliders down the entire coast almost of California. These are large-scale operations where we're having to keep track of the instrument as it's going through human boat traffic. And we're able to actually then pick up the animals along the way, the salmon, the protected species such as the sturgeon, and we're able to get this in real time and know where these animals and domain awareness types of activities for the animals exist. One of the most interesting examples is the Farallon Islands. This is a glider who doesn't pick up a ping in yellow until it comes near the island. We can't see this from our own perspective of aerial surveys. And here's 16 white sharks, just pectoral fin to pectoral fin around the Farallon Islands. So our dream, our vision, which we've written quite a few grants for, including one to Google that almost was funded last year, is to actually have this type of domain activity going on in our backyard, our sanctuaries, test the equipment here, to build acoustic, passively and actively, mousetraps, if you will, that allow us to actually follow the animals that enter into these sanctuary waters. The question becomes, what are you going to do in this case for a white shark that might, in white, these are all white shark positions, go out from our satellite tags to the White Shark Cafe. This is where white sharks meet, and we're not sure what they're doing there. There's a lot of discussion about it. But how would you protect an area like this where we know is a boundary area up against very unique oceanographic regions? And we envision now with a mission that we hope to launch with Saildrone to have a variety of devices in the open sea taking the data from the animals and then being able to send that data back, so much as we heard from our Portugal colleague. To get from here to there, we need investment in the glider technology, investment that liquid robotics or Saildrone alone can't make to speed this up. We need, as biologists, environmental monitoring. We need the ability to do ecogenomics, the ability to use DNA sampling on board the gliders. We're using echo sounders to see prey fields. We need these technologies today. We don't need them tomorrow. We need to be able to follow predator and prey simultaneously. When we take these types of technologies to the remote protected areas such as the Line Islands, where at Palmyra Atoll, we in the United States have invested tremendously in protecting this piece of the Line Islands up at the northern end, we can find out that something as simple as buoys and manta rays can go together quite quickly. So if we put in buoys that are iridium enabled and we tag manta rays with cheap tags that tell us where they are, we can, right up until today, in yellow, right along the strip, keep track of animals that are carrying the tags as they move into the protected area and as they come out. Similarly, in trying to expand the range of using this type of technology, fund it with the Bertarelli Foundation, we've gone to the Chagos Archipeligo, one of the largest marine protected areas on the planet in the middle of the Indian Ocean. We're teaming up with the British and with the Americans at Diego Garcia, and we're trying to envision how do we take this large set of archipelago regions that look a bit like this, and then put in technologies that will wire it up, not tomorrow, but today. And so for this, we've gone with, again, buoys that are relatively, on a big scale, not that expensive. We've gone with underwater receivers. We've gone with lots of animal tags at the same time. So we go for the choke points. We then have spread this technology around the entire archipelago. There's Ernesto Bertarelli there. We've done a lot of tagging in the region. And then now we're getting reporting from a lot of domains that we want to go and make public in terms of where the animals and the assets are. We've also just tested animal cameras for the first time in those domains. We're working on tags that pop up and provide that data back to us so the animals themselves can become watchdogs of their own environment. We're investing now in trying to bring in gliders to help surveil the fishing boats so that we can put the animal data, the fishing surveillance together. There's a lot of illegal fishing out there. And we think that the future very quickly in this region, within the year, might be a place where the animals have their tags, the active monitoring is being done for the human predator by the wave gliders or the sail drones, and then ocean observation is also being done by both sets of instruments. I'm going to end with new tags, tags we need today that we're talking about at Stanford. One of the tags, the ones that we really want to get built right away, are the fish chip tags that are going to potentially bring traceability to our ocean realm. So I didn't shoplift this for today. I did actually find a tag shirt. We all know that when you go into a clothing store, traceability on your actions are right on the shirt that you can't steal. And we think that we should be able to, as common humans trying to protect our marine realm, protect animals immediately by building a traceable electronic tag that immediately is talking to both satellites and RFID wands. And we feel that in the case of giant bluefin, where most of my passion is placed, that when you land a bluefin on this planet, that we should require you put this traceable tag on the animal immediately, rather than electronic statistical documents, which is what we do now, catch documents. and that you should be able to trace from the port to sail in Japan these large carcasses. Because these are our fish, they're not one country's fish, and we need to be able to trace how many are coming out of the ocean right now. We need to replace these schemes from commissions, which are paper documents, with electronic technology that can be traced, and we can then show the commons and show the public what's going on. Similarly, just out of our lab yesterday, in a good session with everyone in my group, we think that a fin alarm tag is possible. We think that the capacity overnight to change the system by actually making a tag, not investing in these huge tracking tags we've been thinking about for so long, but coming up with very small, very, very easy to place technology that allows us to keep track of animals in our MPA, could build in the type of enforcement that we need to actually prevent some of the large-scale finning that's happening. So I'm going to conclude by saying that from our perspective, we need to know what you're protecting first. So we really want to establish that you must be able to census what you're trying to protect. If you can't know what you're trying to protect, you're never going to get people to do it. We need to map the dynamic nature of MPA movements, the animal movements that can help with a lot of participation from Google. In terms of active management, the buoys are working. We need to expand that technology immediately. We've got certainly horizon technologies that with investment will become our marine domain tools of choice. Ocean observing is critical for the planet. We can't say this enough as oceanographers. And then vessel intrusion monitoring, watching the human predator. I'm sure we're going to hear about technologies here today that can do this. And then from Stanford to all of us here, we think the fish chip and the fin alarm tags are tags of tomorrow that should be here today. Thank you very much.